Okay, then what we're going to do is make a start then. So thank you to everyone that replied on the Microsoft form for this question. It's really useful that you do that, because what this tells me is that when I looked at your responses, part A and part B were done really well, whereas part C, there were a few misconceptions on. So I'll very quickly just run through the answer to A and B, but I'll spend a lot more time on this part C. So we've gone back to some pure for the starter question, and we've got a question here on circles. Now, the first thing you need to do for part A and B, and as I mentioned, I'm not going to spend a huge amount of time on this one because almost everyone got this correct, with the exception of 1 or 2 people that maybe just got the incorrect sign. So firstly, with circles, we want to write it in this form. This form is really useful to us because instantly we can see that the centre is -5, 3, and the radius is just going to be the square root of 25, which is just going to be 5. Okay, so I'm not going to spend too much time on that because looking at the responses on the form, almost everyone got that right. The only thing is just be careful with the signs. A few people putting 5 - 3 rather than -5, 3. So C is the one I want to spend a bit more time on. So firstly, what we're going to do is we're going to do a little sketch here. So we've got our circle. So I'm going to call that centre O. And then I've got this point on the circle, which I'm going to call P. And we're looking to find the equation of a tangent to C at the point P. So the tangent here is just the line, line that just is going to touch the circle. Now, before we get started with this question, can anyone tell me what you notice about the radius or the line segment OP? What do we notice about the line segment OP and this equation of the line, okay, or the line that's tangent to the circle? What do we notice about the radius and the line that's tangent to the circle? So I just want to put that in the chat. So just looking for responses, give you a few moments to have a think about it. Okay, excellent. So I'm seeing a few people putting perpendicular, which is exactly correct. And I think this is where there were a few issues with the question. Looking at some of the incorrect answers that I got for this, I think what you've perhaps done is you've only considered the gradient of the radius. So for this equation line, now we know a point on the line, so we know that -2, 7 lies on the line. But what we also need to know is we need to know the gradient of this line. So what we have to do first is work out the gradient of OP. That's the gradient between the centre of the circle, -5, 3, which we worked out earlier, and this point on the line, -2, 7. So to do that, I just do y2 minus y1 on top, and x2 minus x1 on the bottom. Okay, so your y coordinate for the P, take away the y coordinate for the center, and then the x coordinate for P, take away the x coordinate for the center on the bottom. So I think it's also where some mistakes crept in, just being really careful with the positives and negatives here. So make sure on the bottom here you've got -2 minus -5, so we're going to be -2 plus 5. So when we do that, we're going to get 4/3. Okay, now that is the gradient of my radius, but we want to find the gradient of the tangent. Now, I think the misconception here a lot of you have had is that you're thinking, well, I've got to find the tangent, so surely I don't need to find the normal gradient. But if you look at the radius, well, the tangent is perpendicular to that radius. So if the gradient of OP is 4/3, the gradient of the line is going to be -3/4. So we need to find that perpendicular gradient. So we find the negative reciprocal. Basically, what we do is we invert that 4/3 to make it 3/4, and we change the sign as well. So now you have that point minus 2, 7, and you've got the gradient of the line that's minus 3 over 4. I will skip ahead a few steps because I want you to have another go at this question if you didn't get it right. But just to put the final answer, you should get 3x plus 4y minus 22 equals 0. Alternatively, you may have minus 3x minus 4y plus 22 equals 0. Both of those answers would be correct because they are multiples of each other. You could also have 6x plus 8y minus 44. But could you tell me in the chat why you couldn't have something like 0.75x plus y minus 5.5? Because that was a common incorrect answer I saw. So why couldn't you have 0.75 plus y minus 5.5 as your answer here? It is actually the equation of this line, but can anyone tell me why you wouldn't be able to have this? Okay, excellent. So Grace, Dominica, Abby, Yuck, Laura, all saying that they are asking for integers. So whilst you can have multiples such as 6x plus 8y minus 44, you can't have 0.75 or a minus 5.5 in there because it's asking for integers. Okay, so if you didn't get this question correct, have another go at it. And if you're still stuck, either put some questions in the chat and I'll get to it when we get time in this lesson to have a look at it. So I might have a look at the go back over it at the end if anyone wants me to, or just ask me after this session. So what we are going to do, though, our main objective for today is to look at probability distributions, and in particular we're going to look at discrete random variables. Okay, so we're looking at discrete random variables. So moving back into probability is the last part of booklet S04. Now, firstly, we're just going to start with some definitions. So a random variable is a variable whose value depends on the outcome of a random event, and we denote that random event with a capital letter such as X or Y. Okay, we might use other letters, but often you'll usually see a capital X or a capital Y. That's talking about the event itself, and we've already seen examples of that previously. For example, when we've done normal distribution, we might use capital H to represent the heights of everybody. Okay, we might use capital X to denote, if we roll a dice, the outcomes of that event. Now, the outcomes themselves that these events can take, we use lowercase letters such as lowercase x or lowercase y. So typically, if we use a capital X to represent our event, we'll use a lowercase x to represent all our possible outcomes. Now, in this section, we're only looking at discrete variables, which means it can only take certain numbers on. So when we did normal distribution, we would look at continuous data, things like height, things like weight, where you can have, anything between 177 and 178 centimeters. All sorts of numbers can exist in between that. But we're looking at discrete data today. So if you roll a dice, you can only get a 1, 2, 3, 4, 5, or 6 if it's a 6-sided die. You can't get anything between a 1 and 2. So we're going to look at when we look at probability distributions, we're looking at describing the probability of any outcome from the sample space. Okay, sample space, remember, is just all your outcomes written out. We can represent a probability distribution using a table, and putting this on the table is going to be really helpful for us. It's going to show us where all these probabilities are coming from. It just is a nice way to display all our data. Now, one key point to remember here is that the sum of the probabilities must all equal 1. So that's something to bear in mind throughout these examples. So without any further ado, we'll get into the first example in your booklet. So to begin with, we've got 2 bags. In the first bag, there's 3 cards with the numbers 0, 1, and 2. In the second bag, you've got the numbers 0, 1, 2, and 3. You draw 1 card from the first bag and then draw another card from the second bag, and X is going to represent the product of the 2 values that are drawn. So we're going to complete the possibility space for x, so our sample space here. Now I've already done that, and hence tabulate the discrete probability distribution of the product of the two values. Now, just in case you're thinking I haven't added 0 and 1 correctly, remember we're looking at product here, not sum. So just make sure you read that question carefully, because we are looking at product rather than sum here. So in this table, I've multiplied all my values together, and these are all my outcomes. Now, when I write the table, what I'm going to do is on the top row, I'm going to put a lowercase x, and on the bottom row, I put capital X equals lowercase x. And I'll explain really what that means in a little bit more detail in a second. So on the top row, I just put all the possible values x could be. So if I look at the sample space to the left, I can see that x can be 0, it can be 1, it can be 2, it can be 3, 4, can't be 6, sorry, it can't be 5. You should see that 5 is actually impossible here. There's no way that we can pick a number from bag 1 and bag 2 and make 5. But then 6 is possible. Okay, so don't just fall in the trap of just putting 1, 2, 3, 4, 5, 6, 7. Just look at the numbers that you have in that table and then just put them all at the top here. So then on the bottom here, I put all my probabilities. So for example, the probability that x equals 0, well, I can see here in my table, there are 6 zeros out of 12 possible outcomes altogether. So that's just going to be 6 out of 12. Or if you like, that is also going to be a half. Then fill in the rest of the table. So the probability that x equals 1 is going to be a 12th. Then what's the probability that x is going to equal 2? So if you just want to quickly, I'll give you a chance to put that in the chat just to check that everyone's with me. So what's the probability that capital X equals 2? Yep, excellent. So I can see 2/12. Okay, so 2/12 there, or a 6th. And then just filling in the rest, probability of getting 3 is 1 over 12, as is the probability of a 4 or a 6. So the probability that x equals 2, so just to see in this notation, we've been used to using this notation before, the probability that x equals 2 is simply just going to be 2 out of 12, or if you want to simplify it, the 6th. So we'll move on to another example. And also we'll introduce the probability mass function in this next step. So yet again, we've got two spinners, one numbered 1, 3, 5, 7, and the other numbered 1, 2, 3 are spun. And this time we're adding together the results. So I've done this sample space already just to save time, as I'm sure you don't need me to add numbers such as 1 and 1 together. Well, hopefully you don't anyway. So I've got my sample space here, and then I've got my table below. Now, I put my lowercase x first, and then all the possible outcomes it could be. So you should notice that I've not put on 1 there, I've not put 11 there, because it's impossible to get 1 or 11 or 12 or any other number for that matter. So then in the bottom here, I'm putting the probability that capital X equals lowercase x. So this is what you should always put on your table if your variable is x. And then when x equals 2, we can see there the probability is just going to be a 12th. And then when x is 3, which is also going to get a 12th. And then just fill in all your probabilities there. And what we should notice is all the probabilities add up to 1. So it's important that you check that all your probabilities here add up to 1. If they don't, then you've either missed off something or you've included something that you shouldn't. So make sure all those probabilities add up to 1. Now what I'm going to do now is introduce what we call the probability mass function. Normally you won't get asked to write this out. Normally what you'll see this in a future example. Usually you'll get given this in the question, so it's good to be familiar with this notation. So it's good practice to be able to do this, even though most of the time in the exam you'll usually be given it to then do something with it. So if I want to write out my probability mass function, I would write out the probability of capital X equals lowercase x. And remember that probability is going to be different for different values that you put in. So you can see if you put in x as 2, x as 4, x as 12, you get different values each time. So this is just a way of generalizing all your probabilities. So I just put this kind of curly bracket here. And then I just put all the possible probability values I could get. So the probability could be a 12th, and that happens when x equals 2, 3, 5, 7, 9, or 10. Okay, when I put in those values of x, I get a probability of a 12th. The probability can equal 2/12, and that's when x equals 4, 6, and 8. Now, what else do you think I need here? So this isn't complete at the moment. I need to make sure I've got something else. So it's just in the chat if you could put in what else I need to include here. So just give you a moment to have a think about that. Yep, excellent, Tilly. Okay, so yeah, we need to talk about when the probability is 0. So for x equals, not just for x equals 1, but just generally for all other values, we need to say that we get 0 otherwise. So it just makes it clear that when I put in these values of x, 2, 3, 5, 7, 9, 10, I get a 12th. When I put in 4, 6, and 8, I get 2/12. Otherwise, any other number I put in is impossible. Okay, so it's impossible to get 11, it's possible to get 12, a million, minus 20, etc. Okay, so the next example, I'm going to let you have a go at this one. So I'm just going to leave this for you to have a go at in the chat. But what you do is actually put some working out here as well. So don't just put the answer, tell me how you get to that answer. So I'll give you a minute or so just to have a think about that. It's nice and sort of quick one, this one, but I want you to put your working out here rather than just put the value of k here. So I'll give you a moment to do that. So what we want to remember here is that all my probabilities have to add up to 1. Okay, so that's the really key point here. All the probabilities have to add up to 1 here. Because only 0, 1, 2, 3, 4, and 5 are possible here. Okay, excellent. I can see some answers coming through. And excellent, Shona, Dominica, and Laura, you've got some you're working out there. So Shona's put there, she's added up all the probabilities to get 0.8. And then as the rest of you got as well, you've done 1 take away 0.8 to get your k as 0.2. So it's just remembering that the sum of all the probabilities have to equal 1. Okay, remember that's sigma. That means the sum of. So the sum of all your probabilities, add them together, you should get 1. So if we add up 0.3, 0.2, k, 0.1, and the other 0.1s, it has to equal 1. So we know that k plus 0.8 equals 1. So k has to equal 0.2. So I did say earlier that a lot of questions you'll be given the probability mass function and then asked to do something with it. So this is quite a common question I like in the exams where they give you a missing constant, such as this one. So you're told that discrete random variable x is given by the probability mass function as shown here. And what you're asked to do is find the value of k and tabulate the probability distribution for x. So what I like to do with these questions is I like to draw a table first of k, and then I like to do a second table with the correct probabilities in once I've found k. You don't necessarily have to do this first table if you don't want to. If you prefer just to kind of work it out in a different way, you don't have to, but you definitely need to do the second table. I'm going to draw. So first off, in the first table, I put in all the outcomes, 1, 2, 3, and 4. And now I'm going to put the probabilities below. Now, how the probabilities are worked out from this probability mass function, what you do is you do k times x squared. So when x is 1, we do 1 squared times k, which is going to be k. And then we do x squared times k, so 2 squared times k to give me 4k. Be careful here. It's only the x that's being squared. We're not squaring the k as well. It's not in a bracket. When x is 3, do 3 squared times by the k for 9k. And then when x is 4, 4 squared times k is going to give you 16k. So I'm going to put this again to the chat. Can you show me, and also I want to see some working here, how you get k. Okay, so I want to see some kind of working as to how we would find out the value of k. And the hint I'll give you is you're using that fact that the probabilities must all add up to 1. Okay, excellent. I can see some really good answers coming in. Fantastic. Really good. Really enjoying you participating here and putting in your answers and also showing that working. That's fantastic, guys. So yeah, we're going to add up the probabilities here in terms of k. So we get 30k when we add that all up. So we know that 30k equals 1, and then just simply divide both sides by 30. So now what I'm going to do is draw out the table again, but now I can just simply sub in that k equals a 30th. So when x is 1, we had k before, but we know that k is a 30th. When x is 2, we get a probability of 4k, but we know that k is a 30th. So we have 4 30ths, we have 9 30ths, and 16 30ths. Alternatively, you want to simplify these fractions. It's a 30th, 2 15ths, 3 tenths, and 8 15ths. Okay, let me know if you've got any questions on that. And if not, we'll move on to example 5. I'll just give you a chance to get that in your booklet if you haven't already. And then we'll look at our penultimate example. I'll just check the chat if there's any questions. Otherwise, I will move on. So then our next example, quite similar to the last one, we just haven't got it written out as a probability mass function this time. So we've got bias, 4-sided dice. Remember, bias means it's not going to be the probability of getting 1, 2, 3, and 4 is not the same. The number on the bottommost face is modeled as a random variable y. and you're given the probability of capital Y equals lowercase y equals A over Y, where A is a constant, which we're going to find in part A. Oh, sorry, I've done it with X here. This should be Y. So on top here, we're going to have lowercase y, the probability that capital Y equals lowercase y. So then we've got 1, 2, 3, and 4 for all our possible outcomes. And then all we're simply going to do is just do A divided by Y in each case. So for when Y is 1, we do A divided by 1. So that's just going to be A. Then we do A divided by Y when Y is 2. That's A over 2. We have A over 3 and A over 4. So like we did before, we're going to add these probabilities together in the knowledge that the sum of all probabilities equal 1. Now, there's a couple of things you can do here. You could simplify, you could have a common denominator for these fractions to add them together, but what I would do is just simply take out a common factor of A. And then you can work this out, but just in case, you can also just put this on your calculator or use your calculator to check just in case you make a mistake. And we should get that A equals 12 over 25 here. So now I can go back to my table. I'll draw a second table and then just simply sub that value of A in. So get 12 over 25. 12 over 25 divided by 2, so that's going to be 12 over 50, which simplifies down to 6 over 25. We've got 4 over 25, and when I do A divided by 4, so 12 over 25 divided by 4, I get 3 over 25. Okay, check that all adds up to 1, which it should do, so you can be confidently correct before moving on. So it's just left with part C. And we want to be really careful here. Now, with normal distribution, you might have heard me say the inequality sign, it doesn't matter whether it's greater than or equal to. However, with discrete data, okay, the reason why it didn't matter with normal distribution is because it's continuous data. With discrete variables, it does matter. When we say the probability of y is greater than 2, we mean that y has to be, it cannot be 2. Now with discrete data, the next number up from 2 is going to be 3. So if I'm asked for the probability that y is greater than 2, I'm only looking at the probability that it could be 3 or 4. So I just add the 4/25 to the 3/25 for 7 over 25. So quick question for chat this time. I've got the probability that 1 is less than y, which is less than or equal to 3. Which probabilities do I include here? Okay, so do I include 1, 2, and 3? Do I include 1 and 2? Just 2 and 3? Okay, only 2. Which probabilities am I actually taking here? Okay, see a lot of people saying 2 or 3. Do we all agree 2 over 3? Sorry, 2 over 3. 2 and 3. Fantastic. So we wouldn't include 1 because it's less than, but we would include 3 because it's less than or equal to. So I do the 6/25 plus the 4 over 25, and that just gives me 2/5 when I add them together. Finally, the probability that y is greater than 4, it's just going to be 0. Okay, there is no number there in that table that is greater than 4. You've got 4, but you haven't got anything greater than 4. So probability of 5 is impossible. Probability of getting 6 is impossible, and so on. So that would just be 0 for our very last one. Okay, and finally, example 6. So yeah, again, I need to change these letters. So okay, there we go. So quite similar, just a bit more of a complicated maths function here. So if I look at the mass function, I can see I've got 0, 1, 2, and I've also got 3. Otherwise, the probability is 0. So all I'm going to do is just put 0, 1, 2, and 3 in the table. Now, when m is 0, I need to sub this in to this top one here that I've just highlighted in green. So when m is 0, we do 2 take away 0, and then we times it by k. So when m is 0, we're going to get 2k. When m is 1, we're going to put it into the top here. So we do 2 minus 1 for 1, and then we times it by k to get k. When m is 2, we follow this rule that's in green. So 2 minus 2 is 0, times by k is 0. So actually 2 is impossible here. When m is 3, I need to follow the second rule, which is do m take away 2 this time. So 3 take away 2 for 1, times it by k, we get k. We add up all the probabilities to get 1. So we know that 4k equals 1. So 1 divided by 4 is just going to be 0.25. We can now write that table out with our value of k put in there. So we've just got a half. I'm just going to keep them as fractions. A quarter, 0, and a quarter. We're then asked to find the probability that m is greater than 1. So I'm looking at m is greater than 1. I don't include 1. I only include 2 and 3. Okay, they're the only outcomes. 2 is impossible anyway. So the probability that m is greater than 1, I'm only looking at the probability that m can be 3, which is just a quarter. Finally, we're going to sketch the probability function. So we just sketch a graph. I'll just show you what that looks like. I have just nicked this from Gavin's notes here. And we can see that we just put m on the bottom here, and we put all the outcomes there. 1, 2, that should be 0, 1, 2, and 3. And sorry about that. And then we've got our probabilities here of a quarter and a half. So when m is 0, the probability is going to be a half. When m is 1, we can clearly see it's a quarter, and we can also see the same for 3 as well. And when m is 2, we can see that's impossible. So it's a nice kind of visual way that we can see that. So now what you're going to do is go and have a look at the assignment and work through the questions there. Make sure you send the photos in so we can have a look, see what all the excellent work that you are doing. If you've got any questions, I'll hang about on here for a few moments. I'll pause the recording in a second, but please do ask questions if you've got anything that we've done today or anything we've done in the past, and make sure that you're doing the assignments. The next lesson is going to be 11:30 on Thursday. Okay, so we're going to do 4 lessons a week, so we're going to keep Wednesday as the day that we don't have a lesson. But the Thursday lesson is going to be 11:30, and the reason why is that those of you who've got biology, I know you've got some like video field trip that you're going on, which sounds really exciting. So we'll allow you time to get to that, so I don't want to clash with that. So next lesson will be 11:30. Okay, but please let us know if you've got any questions. Otherwise, I will see you tomorrow. But the key points here is make sure you draw those tables. Okay, that's one key point I want to get across. Okay, so unless any questions, I'll stop recording here. But let me know if there's any problems, and see you on Thursday.